So we're back again. Just a second. New link. So we're trying to implement this model. Sorry again for dropping the connection. Now I switched to hotspot. Hopefully that will hold at least. That's not optimal, but it's much better than dropping the internet all the time. So yeah, if somebody wants to know who is what internet provider should not be used in Ventspils, you can contact me privately. So anyways, here there will be the model. So far, I guess you had time to finish it. Well, we had the break off again so far. Yeah, let's wait for some people coming back in the connection. Really sorry for these problems. I believe now it will not drop because at least the internet from my mobile is good. So anyways, we have the model so far written like this. So let's do the same thing as yesterday here with the X projection, or there will be the embeddings, X embeddings. These will be the packed sequence of data. By the way, I will drop in the chat the template for if somebody comes later and all of our issues with the internet connections. So sorry for that. Okay, I believe this one will hold. So the weight embeddings forward, again, this embedding table or lookup table, this is exactly the same thing as just a simple matrix multiplication. And we actually do that in a few lines later. But when we are transposing it for the backward path, like the output, and this is nothing that special. It's just optimization. So the embedding table is optimization here. So there will be the arg max of dim1. So what it means is that I want, so let us think, so the x data. Okay, so this is x data is this large long sausage, right, where we put together everything. So X data is actually the kind of sequence 1, for example. This might be, let's say, that long, right? And then there is a sequence 2 that is a little bit shorter, right? And they are just all stacked together in one dimension. And at the end, basically, each of those stars here represents a vector, and what the shape is, if you look at the shape, then that is all of the sequences, basically not, yeah, so the shape is the batch multiplied by sequences by features. And what I mean by that is that features are one-hot encoded vectors, so that are for each class of words. So one hot encoded vectors for class, right? And then with the argmax, I'm converting that to indexes. So maybe I should even write it in a separate line so it's clearer. So x indexes. So this is what it is. And it's just like the format of having one hot encoded classes. It's what we used before, and that's why I'm still using it. It's not that this should be always like that. Maybe actually in production, usually you would work just with indexes, not with those one hot encoded vectors. but we don't have that much time to really explore that in depth. So, but all of those are just optimizations, by the way. So that's one. Then, of course, if we want to create a new packed sequence, we copy the other packed sequence properties here, batch sizes and the sorted indices, like that. And then we do the LSTM. So there will be the output of LSTM. So that'll be, let's say, YRNN. There will be the hidden state and self RNN, self LSTM forward, and here we're gonna forward the these X embeddings with the sequence, with the packed sequence, and the hidden state. So here again, we'll just in a second do the other tutorial where we will load the pre-trained model of exactly the same model as this one. And you will see why the hidden state is important. In this case, the hidden state is now like kind of holds values for both layers if you have two layers of RNN, but the output is just the last layer output. And also we might look at just some parts of the hidden state. we might look just at the end of the hidden state, like the actual memory of that last part. And also the LSTM hidden state is actually containing of two parts. So let us see what was the part. So it's a hidden state. So if you would like to see what is inside the hidden, there is the H and C vectors like that. So remember that is a tuple actually. So that's not just a one vector as we coded yesterday. So that's one. Then the other part is again, I think quite similar from yesterday. You could even copy that from the yesterday if you did it already. So y prim, just let's call it logits, y logits. This will be the y RNN, and there is the data. Again, the data is the sausage, right, where we again stack all of the sequences together, and we can use the matrix multiplication by self and self WE weight transposed. So the T function works if that is two-dimensional matrices. If that would be something else, the T function probably would not work. In other frameworks, the T function works for the last two dimensions. So here there is the prim, and there will be torch softmax. And of course, if that is stacked, all of our sequences are stacked just in one long sausage. That means that the kind of probability dimension is the last one. So, and again, here's the nice thing. If you use the packed sequence, that is highly optimized for that LSTM that is compiled inside PyTorch, and all other types of those RNNs, and it will work much faster than trying to do the for loops yourself. They use the CUDA implementations of that. Inside the CUDNN, I think they have implemented that themselves. So there will be then y prim packed sequence. Again, the same thing as trying to have different shape for the same configuration. So the configuration is that sausage configuration. It should be sorted by having the longest sequence first, and then in the sausage comes the a little bit shorter sequence and so on. And that configuration stays the same all the way, but the last dimension of the feature dimension, right, that is changing all the time. So that's why we are copying this multiple times. Okay, so that should be fine. If this works, I will copy that in the Jamboard. So if I run it again, let's see. Maybe I forgot something. I hope not. Okay, it works. So yeah. So this is the code that you could use for production versions for other types of models. For example, next week when we'll look at the reinforcement learning, the like LSTM and RNN models that are production ready would be quite desirable, because in those settings, all of those like Markov decision process of having just the last state, you will see that next week is not always the best solution. So sometimes it's good that you have history encoded inside the kind of memory vectors, you know. So this is like your first kind of real model that can hold memory over the sequence of events, and you can of course like predict like stock market and all sorts of things with this kind of model. So this is this is the model for the task 14.2. I'll drop that also on the Jamboard. Now I will open just in a second the task 14.3, and that will be the coding of the rollout itself. So actually like kind of simulating the production usage of these models. So this will be the 14.3. Implement LSTM rollout. I will give the template in the chat as well. Rollout for pre-trained model of recipe generation. Okay, so add this one here. Just a second, dropping that template. So that is 14.3 template should be on, and in the Mega I also will share it in a second. So if you run that template for the first time, it should download pre-trained model. So this will be the rollout template. I will show you just in a second. So the model should be the same, actually, what we just implemented. Maybe the naming and stuff is a little bit different, but it should be generally the same. And the model is like it's just trained with the whole data set. Actually, not with fully with the whole data set. It has the limits of sentence length with the 20 words, and the training, like the pre-trained model, these plot look like that. So this is the pre-trained recipe. Oh, it's really struggling with that word. Just a second. Yeah, it was like that. Recipe is model, and as you see that the kind of accuracy actually went up quite a bit. So there is a 100% on the right. So it's not perfect, definitely. It's also not really converged, but it took a long time to actually train it so far. I think it's since yesterday evening when I ran it. So I'm also not sure like how well it will work, but at least that's something that we can work with. So please get that template, and try to run it, please, and let me know if you download the pre-trained model with that line that I included in the code. So just a second, let me find my own code here. So here there is the lines of 34, where it downloads from YellowRobot website the model, the pre-trained model here. And at least for my Mac OS, it has some issues sometimes. So, but hopefully other operating systems it works. So just I will share the code itself like that. So please let me know if you have the template and if it is if it's able to download that pre-trained model. Do you have the template 14.3 and model downloaded? Plus minus, if minus, please let me know what's the problem. So well, wait a little bit so you can catch up with this. So I see that at least some people report that it's working. So that's great. I think it depends on the system. Sometimes the SSL certificates, there was some bug, I think, in Open SSL or something. That's why it's struggling on Mac OS sometimes. Okay, so but if there is a problem with downloading, you can download it using the browser and then just copy in that path. So that's good. So we have the model here. So one thing first is that if you remember, like we talked about already, that if you have pre-trained weights, we can load them, or also we can save them, of course, like mini training. And to load the weights, there are some functions like torch. Just a second, I don't want to make it a little bit of problem. I'll just find some of my examples that I did before. So one is that, and also save these weights with CPU configuration. So it's a common mistake when you save the weights. You can forget to move them to CPU if you're training on GPU, and then it will be a problem. So that is one advice that I can give you while I'm looking for some of my examples, so I don't mess up something. Like I know there is a torch load, and there is a state dict, but okay. So I found it. Okay, so there is a model load state dict. So that will be one, and the parameter for this one is the state dict. So state dict parameter here. That will be the torch load, and in torch load we will use the code of that I have up here. Sorry for scrolling, but you can copy it yourself from line 35. So this path model 17, that one. And just in case, so in this case this is not the case, but just in case if you have some problems, you can load it from map location here CPU. I think it's not really safe to load it from GPU directly to GPU type of those tensors, because the GPUs are a lot like different from each other, but the CPU tensors should be the same. So one also is that like the model, as you see, it is depending on all sort of hyperparameters like hidden size, layers, dropout, and so on. So usually, actually, what is recommended is to save hyperparameters, recommended to save hyperparams as JSON or some other format, and then load them like here in the construction of the model. But in this case, because this is just a very simple example, we don't have actually like proper arg parse, you know, at the front, like we talked with about the tensor board, right? When you do actual research work or production ready models, you should do the grid searches, arg parse, and then the hyperparameters will not be the same for each of the runs, and that's why we need to like store them somewhere so we can load them before using it. Interesting. Interesting. So I see the chat that there is also some problems with SSL. So maybe that SSL issue is not specific to actually Mac OS. And running CUDA with all the samples, that's also interesting. Why would that happen? I think there should not be all samples. I don't see any place where it calls all samples, hopefully not. So, okay, we're loading the pre-trained weights here. So that's one. Then one thing that usually you do is model eval. So that is when you turn off the, this way you turn off the dropouts, turn off dropouts. But in this case, we don't want to turn off dropouts. We want to use it a little bit unconventional way. So we use train on. So the dropouts are not disabled. But what we want definitely disable is torch set gradient. Set gradient enabled, false. So we don't want to accumulate gradients. Remember, when you are calling forward pass, it remembers a lot of stuff. So when you would call the backward pass, it would then kind of yeah. So it would then should not again call the forward pass, right? So we don't want to do things twice. So that's why we should disable the gradient accumulation. It will make it a little bit less footprint in memory, and it will work better as well. So that's one thing. So let's think about some other things. So so let's then make the main our kind of game loop, right? Remember when in the very beginning when we made the asteroid game, we also had the game loop, right? So here we'll have the input string. So x string will be the input. It will work in console, right? So x, please input x here and exit with the q, for example. So if I drop in the line /q, it will exit this loop. So we can also immediately actually make that check. Yeah. So if x string is this q stuff, then we want to break out of this. So we will enter few words, and then we want to see what the model can predict from our few words. So that will be our use case, basically, the rollout function, basically. Yeah, sure. the sentences are quite a lot, but there are even more, I think, because as I say, I limited the number of sentences with the maximum of length of 20, but if so, not sure. Like it's like if you would have maybe if you the full length sentences, the sentence count would not change, but the data will be more. So, anyways. That's one thing. So let's call then X a list. There will be our data here. X string, we will split it. By the way, but we should use the method that we have with the word tokenize, and so the sentence tokenize and word tokenize. I copied these things from up here. So here will be just the sentence. So this will be the sentence. There will be X string here. The sentence lower words here. That's great. So we'll use that one. Then we will go through that one and collect the indexes. So because we might enter words that are not included in our vocabulary, and we should probably then make some kind of warning message and kind of not allow to do that, because otherwise the output would be like it would just not work, because we need we have limited amount of those vocabulary words. So let's go then for word in words, and let's look for index xidx. It is from the full data set, so the words to indexes and word, and before that I guess we need, or maybe we could just have the try and catch here like that. I don't know what was the missing stuff here. If you know what is the exceptions, there are some nice exceptions, especially for missing keys inside the dictionary. So if you find out what was that exception, you can drop it in the chat, and then I can use it. But by the way, for this task, you need to have max length. So for this task, you need to have max length none, because otherwise it will not work, because it's pre-trained using that that max length. So anyway, here we'll write then print the word not found in vocabulary. So we should not use that word, and you should then do something else here. So we'll break out of this. Let's make it this as then as zero, as an empty list, and here break, and let's say if this is an empty list len, then we want to just continue for another run like that. So we are collecting those indexes, and we need to add those indexes to this stuff here, append x idx, right, like that. So we have the indexes ready. Then the next thing is we should convert the indexes to one hot encoded vectors. In this case, I don't want again to scroll around and like disturb your work, so I will try to open this file again separately in other window. So this is again also experiment, kind of exciting to see how well it will work for myself as well, because I didn't have time to actually test it out, but it will work most likely. So let's see. So the easiest way to convert it to the one hot encoded will probably be X. Here there will be NP, or maybe we should start working with torch immediately here. So torch of zeros with the size of, so this will be the torch zeros of the size of the length of the indexes, comma, the whole data set, dictionary, max, classes, tokens, like that, right? So that is the template for the one hot encoded stuff. Then we will go over here with the torch arrange. So we are selecting only those elements that we want. So these will be the length indexes, and for each of those indexes that we select, we will choose the real index value, except this might not work, but hopefully it will work, because this is actually the integers, but the other things are torch. So let's see, like that. If it will not work, we can just easily convert it to the torch vectors, but hopefully it will. So again, I probably will drop in the Jamboard some parts of it already, because otherwise everything will not fit in one screen. So in the 6th slide, I will drop the first part of the loading stuff. So the loading model. So that is in the 6th slide, and the bottom part of actually using the model with this main loop, we will share it a little bit later. So that should be fine so far. So what else? So we need actually the hidden states here. Okay, we could actually skip that part, but let's do it with the hidden states in here, so that you would better understand how it works. So let's see. So there will be two hidden states. One will be the hidden, and we will initialize it by zeros, torch zeros. So here the shape is the layers batch hidden size for that structure. Also exactly the same thing will be for the cell state. Actually, I just realized that I could clone it probably. So we clean cell torch clone. Right, so I think I can clone it like that just. So that's great. We have those two hidden states. Now we also wanted to define some kind of maximum rollout. So let's see, this will be the T in range of, normally the rollout should go to the max length, but we could experiment a little bit and make it longer. So integer of max length times 1.5, so we can even roll it longer than it was actually trained to be working with. So that would be interesting to see how well it will work. So that's the. That is good. The only thing here with the x's is that I'm missing the batch size here. So we should convert it back to x should be the x on squeeze dimension of 0. So what I want to do is to have batch 1 comma, let's, we can add here as well b. So batch 1 comma sequence comma one hot encoded features, right? That's what we have there. The other thing is that we want also packed sequence, so but I don't want to do it here actually. So okay, let's do the packed sequence down here. So okay, so X sequence or X packed should be then using again the function that we already used before. Need to find quickly that code part so I don't use the wrong function. Okay, padded sequence. Padded sequence of X, and the lengths here, that is something simple. So this we should somehow add it automatically. So that should be actually okay, let's see, torch along tensor, and if I would call it as length of not actually, I cannot do that, but X shape, or the size is basically the same thing as shape, but I like its size a little bit better. So the sequence, so that is the length basically, or maybe we should just write it out so code would be readable. Lengths. So the lengths in this case, just one length, that is the length of that one sample that we were working with. So that's great. And the batch first through. So this, so far so good, hopefully. Okay. So now let's have the calling of the actual code here. The model, I mean. So for the model calling, there will be the X. I mean, this will be the Y prim. And here there will be also the new hidden state and cell state, hidden cell, like that. And this will be then the model forward of the packed sequence, comma, hidden and cell. Again, if you look at the equation on some of the first slides, you see that the LSTM have two vectors there. That's why we have two tuples like here. If that would be a vanilla RNN, there will be just one hidden state. So that's good. The hidden state is our memory, basically. So that's what we have so far. Then let's think. Okay, so we actually interested in predicting the next time step, and I also kind of don't like that I accidentally used here was something that I didn't want to use. So I wanted to show you the effect of the hidden state, but I accidentally started using the whole sequence. Interesting. We could use it like that as well, probably. Okay, so the input words are there. So words that we have up here. Okay, that will be great. So I have idea how to do this. So yeah, in the first time we run, we will give the whole sequence and then collect the hidden hidden state at the end. But for the next time we run it, we don't want to run again the whole sequence anymore. So what we do is first of all select what will be the next predicted word. So YIDX, that will be the next predicted word. So and that will be the last one in that sequence. And that is actually, unfortunately, again, so basically what we can use is data minus 1, so that will be the last word in that sequence. And there we can use the I guess the argmax. So this is a probability distribution of that last word, argmax. So let me think that there will be, yeah, so that should be fine, like that. And then we just need to define the new x here. So the new x is, in this case, the same x as before, like that, but just now it will hold just that last word here, so there will be just one. And if we want to not have the unsqueeze there, we can have the batch also here. So what it is batch, sequence, and features, and in this case we're just running the last word and we're using the memory, and the memory is the hidden cell. So that's why it works. It should work at least. And the x here will be from the 0, 0, and the y idx as 1. And I'm using, why I'm not just taking the last probability distribution from here and just using it directly is because there could be a situation that it predicts that the next word is milk, for example, and the prediction is 90% or 80% or something. And what this model works only with the one hot and colded vectors as an inputs. So I'm just like kind of like redefining with argmax. You can probably do that also by using some other method. I don't know, like even I don't know, like, but yeah, argmax works good. So like that. Hopefully this is fine. Not really confident that it will work with the first try, but let's see. So that is one, and let's add also the predicted word to the words. So the words will be append the new predicted word, that will be the dataset full idx to words, y idx, and at the end we just need to write the sentence. So print, so there will be the output plus this will be the with the spaces in between, join words. What I try to show you with this rollout, and what I wanted to do this like together with you, is because as you see in this code, we are not running the whole sequence every time when we go to the next word. We are doing the just with the memory. So we run first time the whole sequence that we just entered. Of course, you can actually do the same thing by going step by step, like and like accumulating the memory beforehand. But we are feeding in the next prediction as next input. So that's why I'm doing it this way. Also, there is another thing missing. We have the token for end of the sentence. So the end of the sentence token. So if this is the words is, I mean the last word is the dataset full token and token, then break. So there is a specific token that says that this is end of the sentence, because the end of the sentence can be before the max length, of course, right? So if this works, I will copy this code to the Jamboard. So maybe I should start copying it because some of you are, when you're following. So and copy this first part. I will copy the first part now. Okay, well, it's not copying, right? And then I will copy the second part. Okay, so we'll see if there's some problems, then we'll use it, then I update it. So I try to run it now. Let's see, running. Oh, okay, there is a problem. The max length is not. I know, I used the wrong thing here. Max sentence length. Sorry, nobody corrected me. Sorry for that. This max length, again, this is not a good variable name. If I would do the code review, I would like slap myself because that was not a good variable name. Max length, like the bad variable names. The competition is the max length, the data set, string, value, all of those you should never use. Like it doesn't say anything. So it's the best, I mean the worst variable that you can use is name is data. So here this is max sentence length, and the previous max length was meant to be max samples in dataset. And if I don't make a correct variable name, I confuse myself even. So if I run it now, let's see, hopefully there will not be problems. Anything could happen actually, like starting from the incompatibility with the model, but I hope that that's not the case. Okay, got it. The one thing that could also be is it's loading very slowly because there might be huge matrix, but still, why it's loading so slow? Let me check what is happening here. It should not be loading that slow. Okay, the tokenization, right. It's trying to tokenize the whole dataset. Yeah, that is again something that would be better to pre-compile and then save. So the vocabulary should be also saved, not run every time when we run the code. Otherwise it takes so long. Let's see what I can do. So in the Jamboard I have the code, by the way. Maybe I could somehow pickle this and save it so that when I run it next time it would not be repeated. If you want to do that, you can do that as well. So let's try to pickle this. So Python, not Python, but here the is pickle is so if that is not pickled, but basically I think the pickle already constructs it without the constructor. We'll see that in a second. So I'm running it. Takes me so long time to just process the sentences. I think yesterday it worked a little bit faster. Okay, this is not cool. I will add some information here. No, but if the sample sentences appear, that means that it's already done. So anyways, we will try to fix it. Hopefully it will be pickled without the constructor. Okay, there is a C pickle and pickle, but oh man. Yeah. Okay. Pickle. Import name. Dump. Okay, like that. With open. There was the path of dataset, right? F path of data. This will be the dataset full pickled with the writing operation as FP. And here the first parameter should be object. So dataset full fp, and that will be the first time we run it, and the second time we run it, I don't want to do this. So if OS path exists of this path, then I want to just load it. Else this happens. Somehow forgot that it takes time to convert the dataset. Okay, nice. Somebody is sharing the error that you're getting, so I can help out with that. While for mysterious reasons, the dataset part works so super slow. I will have to figure out that part as well just in a second. So the load, maybe it's also great to show you how to do this if you didn't know already. The read. Okay, so this should work. I will add that to the Jamboard as well. So this should avoid you having to process the whole dataset every time you run the code. Okay, what is this one happening, right? But I don't really like that it is so slow right now. Just a second, I will check my htop. I'm not sure really why it's so slow. Okay, it worked. Great. Took really a long time. So add. Okay, now I have some errors here. First of all, next time I run it, it will pickle the dataset, but I have some errors already. Okay, that's the wrong place, but the lower part, so the sentence, the string, so I input just one word, then that's a problem. No problem, we can manage that. So if there is a space, then we will use it like that. If there is no space, okay, there is a bug here, obviously. So the lower should be here in this part. Right, so that is obviously a bug. And also I will check the bug that you reported in the chat, no worries. By the way, of course, if you could fix it yourself, that would be great, but I will help you out. So the first part should be changed a little bit with the lower in the correct place. I should also start running it because it took me so long to process. So I'm running it. So this part should be updated as well. Right. So that is updated, and the bottom part from the continue I also will update in the Jamboard, and then I will look at the error that you're reporting and we will fix it quickly. So I think today we'll probably, unfortunately, it will not get to the transformers. I will do the transformers next week, and we'll have an extra one lection to cover the material. So, but that's better than just trying to squeeze everything today and then be like really mind blowing. So, okay, let's see what we have here with the error. So I'm getting the error of the param shape. Copying with the size mismatch of the embeddings. Very interesting. So if you see in that error that you're saying that you're getting, But that's really strange. Why would you get it? Probably that is because of the end of the sentence token. Here there is an end of the sentence token. But if you use the template that I gave you, I used the same template that I gave you. It should be there. Max classes tokens. What you could try is to just do here -1, but that's a bit risky because I'm sure, like, why would it not be there? But I will double check the source code for that part. So in the original source code that I used for the training, they also have the end of the sentence token. Maybe that is something with related to the okay, I have idea what I'm gonna do. I will pickle my class here, and then I will give you the pickled version, and you can then try to use that one without using the dataset like pre-processing. I will just send you this file, pickled file, and you can just then skip the dataset creation and just load it from the pickle like that. Then it will match the same tokens as my version. So that's another point to remember for the future. You should always save the hyperparameters and the tokens and everything along the module. You should not try to reprocess it and then run it. So that is the problem, I guess. Yeah, or maybe the other. Yeah, no. It seems like that this is because of the token mismatch, right? Okay, now it's saving, right? Except something very bad happened here. Dump object file pointer. That is good. Argument right must be string. What is this? Just a second. If this simple pickle will not work, then I could use the C pickle. Why would argument must be string? That's interesting. That's really interesting. Okay, got it. I need to have it in a byte format, WP and WRB. So we'll need to run it again. For the homework, I think I will give you like interesting task of using the like a little bit more advanced architecture of the RNNs, but not using the equations, but using some of the pre-made stuff. So that will be quite interesting, I think. So maybe even some of the state-of-the-art versions, so with the layer norms. You already remember about the normalization layer norms and other things. So, okay, now it's processing for me the checkpoints. Okay, now, great. I processed it, and now my processed version is in the wrong format. Dataset full, this one should not be there. Run it again. So at least you can write already the pickle code. So the pickle code should look like that. You can even probably just have these 3 lines or just 2 lines and delete the or maybe delete the dataset creation part. And later I will update also the template so others later working with this would not have the same problem with the processing dataset with wrong tokens. My guess is that the cause of this is because this natural language toolkit model might have different version, or maybe the Mac OS kind of encoding of the strings is a little bit differs, or something like that. You could, one thing that you could do while you wait is to double check, please, if in the where there is the please check if the words to indexes contains the AND token, and that is the length here with this one minus one of this one. So the last token should be AND. You could check if this is the case. And maybe in that way you could a little bit debug it or fix it. So it's still running. As soon as it will be finished, I will give you the link. And I just wanted to make a new data set, pick the recipes, wanted to make something fun. Before, like with other courses, what I have done already, I made maybe that's inspiring. I made with other course the Twitter generator for Trump. There is the Trump tweet dataset that was really fun. Then I also made like with the students together the joke generator. Then we made the quotes generator. Then we made the Shakespeare generator. Now I wanted to make the recipe generator, but I forgot that I should save all of the parameters beforehand and not to do this to wait for them to be processed. Yeah, please let me know in the chat if you can double check why the tokens are mismatching the shapes. Maybe you can see if that's related with the AND shape. Do you have the AND token in your vocabulary? You can also double check the like maybe the word counts or something, like if you see something weird there. Yeah, it should be ready soon. Meanwhile, I will double check my code down here. So the X, it's creating the one hot encoded vectors here. There is the hidden and sol state. The first time this code runs, when the t is 0, it gives the all of the like words that the user inputs just in one go. But the next time when the t is 1, that is the t plus 1 predicted time step, we do not use anymore that part. Okay, so great, it worked. And now I want to double check if it can load as well. If I run it again. Okay, let's see how big is actually my pickle stuff. Okay, it works to loading as well. So I will send you just in a second my pickle version. So it works so far. My pickled version is 26 megabytes, so it's not too bad. I will probably drop it in my YellowRobot share because later I want also to send it to you. I want to make it in the code automatically downloadable. I should also check my SSL certificates. I'm not sure why people are saying that it's not working. So anyway, if you know why my SSL certificate is not working, please let me know. So let's see. So this will be YellowRobot share and this file. Okay, cool. I'm now sharing that just in a second in the chat. Having the error, the words tokenize. So I just shared the link, but interesting. I'm having the error for word sentence tokenize expected or byte type or bytes type. I think this might be related to the Windows. Maybe you need to do some kind of like encoding change or something like it might be problem specific to the Windows type of string encoding, because Windows has really strange encodings. So, but anyways, I just shared the pickled version of that dataset full. So I dropped it in the chat, and I will also copy that one here in the Jamboard below, so you can find where to download it. And I also will try if it works actually. So now let's see. So the pickle version, right? Let's see, add. Okay, there is the error with the bytes as well for me, but this is in the other place, I guess. Tokenize. Okay, I have the same error, I guess. Let's see. Interesting. So I shared you the pickled version of the dataset. And now I will just quickly fix this part. So add, let's see what we have here. X string, that is correct. Then the sentence, that is correct. Sentence is correct. Then the sentence part starts lagging. Okay, I will try with the two words. Okay, why it's so slow. Add milk. Okay, it still crashes. List, that's strange. Okay, I think I know where the problem is. How did I use the word tokenize? Maybe I did it a different way. No, that is the correct way. But I think maybe the output of the input function is something, but because there is a list there. Oh no, I got it. So got it. So that they actually don't need the sentence tokenizing, because we will only do one sentence at a time. I don't know why did I left it there. So we just need the words. We don't need the sentence at all. So this part, okay. So I will update this part in the Jamboard as well. The sentence tokenizing was because there were many sentences and we just wanted to work one by one for the sentences. Here for the rollout, we will work with just one sentence. So like that. But of course, you can later make it so that it works with multiple sentences. You just need to reset the hidden state between the sentences. So, trying to run it again. So I hope I just answered with this error. So add. Okay, there is a other bug. Okay, this bug is not so bad now. So add index to word. Hopefully it's not so bad. We'll see. We'll see about that. So okay, I'll add the breakpoint there. At least the rollout code for the first loop works. Add. We'll see what we get here. So indexed words. So there are these guys. This is good. Okay, I know where the problem is. So again, these are not the normal like scalar values of the Python. They are not integers. They are tensors. So we need to convert them to the integers. So we can do that by item function or by data, and then select which dimension we like. So I will also update this part. And maybe especially like draw a circle around that place that should be fixed. So that's actually great that by working out these mistakes, you see what is important to remember building these models. So, okay, running again. Okay, add. Okay, great, it worked. Add joint, cubed fingers, blend, season, batches, burst noodles, add milk and cooled face down medium shortboard across the golden. Okay, when it starts going like in a very long sentence, it starts making nonsense. But basically, I guess next time when we'll work with that with the transformers, the long sentences would hopefully work a little bit better. Normally, the RNNs would cover, let's say, are up to 100 words, but still this is not 100 words, so I guess it's not fully trained. So add milk and sugar. So add milk and sugar to Birsky rib platter. Okay, maybe this lot of sentences do not start with add. So maybe I should look what kind of examples do we have there. So, okay, let me know if you get it working so far. Did you get it working so far? I guess when I'll give you the homework for the more advanced model, if you train it, you'll probably get more exciting results. But to have this one also working, what I want to do is to look at some example sentences at least and see what kind of sentence beginning should I use to produce something more sensible. So let's see, data set full, like that. I will take 10 examples. Okay, using fingertips, season to taste with salt and pepper, add flour, sugar. Okay, that could work. Add flour. No, I don't like this. Add flour, egg, maybe. Add flour, egg pizza. It's not really trained, I guess. Brush pork with olive. Brush pork with olive fluid. And then there is a sausage beaten. Transfer to a bowl. Let's see this one. There are some really bad things in the dataset. As you see, there is divide with this like a minus sign in between, and all sorts of things that you should not be probably added in the dataset. By the way, the other thing is we can check the effect of the dropouts. If I run it again, it will give me a different output every time. So that's a really cool thing. Transferable aluminium containing the C-pods shaggy, which after about like I guess about the 10th word it starts giving nonsense. Transferable drizzling containing dish. Let me think. So one thing we could do is try to reduce maybe the dropout. So what would happen if I okay, we can first try to turn off the dropout. Just using this line. Run it again. So I see if you have some errors mismatching the shapes, you should definitely try my pickled version. With pickled version, it should work. I will also prepare later the template for with the proper pickled version. So let's see, heat large. Let's see what will give me with this one. Heat large, and if I run it again, it should give me the same answer because the dropout is turned off, and this is the case. Add almond, add almond, add milk. Okay, this this model is not that great. I think add uh, floor. Mm. Okay, basically, it's not great model, but at least it works. So you know how to train it, and you know how to make it better. You just need to train it longer, fix the dataset. By the way, I think this is a great example of. So let me turn back the dropouts on here. So I think this is the great example of having the dataset clean. So if your dataset is if your dataset is not clean, then there's this old saying like junk in, junk out. So if the dataset is not clean enough, the result is also not great. So what I think for the next time, it'd be great to see if you can train and roll out some models with better results. You also have the access to the university computers, the GPUs, where you can train it. And yeah, and also for the transformer models that we will look next week, maybe I should clean the dataset a little bit up, because if you look here, like in the training dataset, we have all sorts of strange things like. Okay, this time this was not so strange, but there were you saw there was like this one, like comma 04, that is definitely should not be added to the like words and some other things. So again, it would be great to make a histogram of all of the words that we have in the dataset. Maybe since we have a little bit of time, and at least this one is working for me, and hopefully it will work for you as well. I should maybe look at making some histogram here. So just a second, let's see. So plot. Let's try to make some histogram of the most common words in vocabulary. Maybe we should kind of clean it up a little bit. I mean, like for the training. So for the testing here, we cannot do anything at this stage because already it's trained. But for the next iteration of training, it'd be nice to fix it a little bit. So the bins of the histogram, right? Let's see. Okay, so I have it. Where do I have it? It's loading, dataset here. So this is optional. You should like it's a. You need to just make that this code works for the rollout, but just for the future, for the next session, I want to make sure the dataset is a little bit cleaner. We'll try to show you how to do that. Okay, so dataset. Here we have the word counts. That is what we want. Word counts. If you create that to list, I think, how I could do that. So this will be the word count list. And here I will take it as the key value, and probably there's an easier way to do this. Key value in items. Hopefully that will work. Yes, this is good. So, and then I want to sort it, of course. Sorted by this one, key lambda. Lambda functions are these delegate functions, sometimes called, they are just temporary functions of the code. So IT of 1, so I'm using the values, and what was the reverse? I think reverse true, right? So now the highest number of the values will be first, and the lowest will be last. And let's see. So here, actually had somewhere the code for the histograms that would be looking nice. Since we have a little bit of time, I will do the histograms with you here. So that's one of the things that should be done when you're working with proper data pre-processing. There are a lot of steps actually. For example, augmentation. Like we're not looking at augmentation anywhere. Like for example, if you have the image dataset, you would never want to just train it with the raw data. You would want to augment it. So let's see. Okay, my computer is freezing. So the dataset exploration, I had some files like that. Let's see, histograms, plots. What kind of plots? Okay, bar charts, right. That was the one that I wanted to use, not the histogram actually. So it will be histogram, but it will be made manually, not like automatically. So plot figure size, of course, that's first I should change. So it should be then the width, let's say 5, but the length, the height 15. Okay, by the way, let me know in the chat if the rollout works. Is the rollout working? Plus, minus, if there's still something not working, then let me know exactly what. And if something is not clear why the rollout works, then also let me know. So plot here this one, then let's see, we'll have the some kind of, yeah. Okay, plot the bar chart of horizontal version. And actually, I don't want to include everything here. So let's include the top 100 probably. So top 100 samples. And P a range of the length, or basically we already know that that's top 100, but whatever, like that. And then there will be the values. The values will be here like that. So IT, this will be the value for IT in. IT is iterator, so that one. And the tick label. Tick label will be the name of that token. And then plot show. And then I will copy also this code if somebody wants to play around it or clean it, clean the dataset. Okay, I see that at least 2 people are running the code fine, so that's great. As you see, the result is not excellent right now, but we will try to explore it a little bit why it's not excellent. So, okay, let's see. I reversed it. Why it's so the reverse means that the first one should be the biggest one value. But my bar chart, okay, maybe it starts from the bottom up, probably starts from the bottom up. Okay, so let's see. So can I zoom it in? So the end token is the most common one. So that's the sentence end, and that's actually good news because it's not always ending too soon. So the weighted cross entropy works. Then the comma and point. So the point should not be there because that's the same as the end probably. And then we see actually zip flow. Maybe I should drop some. So the zip flow is the language law where there is the and, to, the, in, a, with, until, off. All of those things are like very short words that are much more common than any other words. And then we see something already strange happening. There are the semicolon, for example. Semicolon should not be there. There is also these like brackets that is also not cool. Then there is a simple colon. Other things I think are fine. I just don't like all of those, like the colons and stuff. And maybe also the model is not properly trained. Maybe the parameters are not good enough. So anyways, that's a good way to explore. You can also, of course, reverse it another way and just look what are the least common words. We will probably do that as well just in a second. I will drop this into Jamboard, slide number 7, so you can explore it a little bit. Maybe actually I should not give as homework to make the like state-of-the-art type of, or not state-of-the-art, but basically more like stronger RNN model. But maybe I should give you a task to just to use what you know already, all of those any kind of RNN model like pre-made, but just work more with the data and clean it up and come up with the best result that you can. So maybe that could be one way to do, but I will think about it. So just let's see. I think like I don't want also to make that your homework is too difficult. So I'll think about it. So there is the histogram. Histogram I will add to the Jamboard as well. It seems like it's not copying to the Jamboard for some reason. So if I copy it here, save as file. Save as file. And then as PNG. And the last thing I want to do is to change the order and see what other words do we have there on the lower side of the tail. So definitely we can see that the some of the punctuation marks should be removed. So false, so we can do it like that, and if we run it, let's see what we get there. 100 least used words. Okay, so these are just one case sentence. That is a really important thing. So we should never include the words that are used just once. So these are used just once. And basically these would get quite a significant loss signal, and they are probably not good for the situation here. Yeah, you can see also there's some strange signs here, like this box here or the slash in the middle of that. So probably all of the words that are just repeated once should be filtered. So what I mean how to do that is here. If you look after the processing, we could do here another loop where we just filter out all of the words that are just repeated once, some things, and up here we can also filter out the punctuation marks or strange characters or whatever. You could also play around with the tokenizer algorithms. They have some better than this one in the natural language toolkit. Maybe some other would work better. So anyways, that's it for today. I know there was problems with the internet. Hopefully next week it will be fine. And we didn't get to the transformer today, unfortunately. At least now, hopefully, you understand better all LSTMs and the way how all of these sequences and the rollouts work. And next week we will look at transformers, and then we will look at the deep reinforcement learning. So there will be an extra session probably. So that's it from today. Hopefully it is interesting. Hopefully you can